What's going on, Algebros? In this video I'm going to show you how to complete problem 1 of the written work for module 6. Basically, in this written work assignment, you're to use your graphing calculator to sketch some graphs and then use your graphs to solve inequalities. As you're going to see in both the videos for problem 1 and the problem 2, part of this rests upon using the intersect feature of the graphing calculator. That's one phase. Then the second phase is to interpret the inequality and look at your graph to identify which parts would help you solve that inequality. The last phase is to look at the corresponding part of the x-axis, the part of the x-axis that corresponds to the pieces of the graph that are relevant to solving the inequality. I know that sounds a little bit much right now, so let's go ahead and dive into it so you can see just exactly what I mean. So in problem 1, part A, it says let y1 equals 3x plus 4. And as you can see, I already have this sketched out. I typed these equations into my graphing calculator and just sketched out what I saw in the graphing calculator. And you can also see that I'm using the standard viewing window settings. So y1 is this dark blue line. y2, which is the equation y2 equals 1/3 quantity x minus 2, is the green graph. Of course, I labeled each of these as y1 and y2. Also on the x and y axis, I labeled the x-min, x-max, y-min, and y-max. It isn't critical to solving the problem that you label these tick marks, but it would be helpful, especially for grading purposes, that you guys get in the habit of labeling the x-min and x-max, especially if you're going to use something that's different from the standard viewing window. Alright, so basically part A has already been done. So I'd like to go ahead and get to the real meat of this problem, which is part B, where it says use your graphing calculator to solve the inequality y1 is less than or equal to y2, and we're going to provide our answer in interval notation. Alright, so this is a skill that's probably new to you, so I'd like to hit hard or riff hard on this one. Actually, one key item is going to be the point of intersection, which it looks like these graphs are intersecting in quadrant 3. And using the intersect feature, you would find that the coordinates to 2 decimal places would be given by negative 1.75 as the x-coordinate, and then the y-coordinate would be to 2 decimal places, negative 1.25. It's actually the x-coordinate of this point that is going to be helpful for us, and as you're going to see, it's going to be part of our answer when we put it in interval notation. To solve an inequality, once you find the point of intersection, go ahead and make a tick mark on the x-axis that corresponds to the x-coordinate that was given by the graphing calculator. So right above the point of intersection, I'm going to put a tick mark there. Hopefully it doesn't tick anybody off. Just kidding, by the way. And I'm going to label that as the value of negative 1.75. Alright, so what's the big deal about that? Well, I'm going to jump back down to this inequality where it says y1 is less than or equal to y2. When you read an inequality like this, obviously you want to read it from left to right, but how you interpret it with the graphs, that's kind of the newish and key thing here. To say that y1 is less than or equal to y2 means that we want to look for the parts of the graph of y1 that are under any parts of the graph of y2. So to do that, let's go back up to the point of intersection, and we're going to look to the left and to the right of it. We're going to try to figure out, okay, well, is the graph of y1 underneath the graph of y2 to the left of it, or is it underneath the graph of y2 to the right of the point of intersection? Alright, so let's go ahead. Here's our point of intersection. If we look at what's going on to the left of it, we can see that the green graph is above the blue graph. Stated differently, to the left of this point of intersection, that's where we're seeing the graph of y1 being underneath the graph of y2. I'm actually going to go ahead and draw a little arrow to that piece of y1 that's important for us. This piece of the graph of y1 is underneath a piece of the graph of y2. So I'm going to write it this way: y1 is less than or equal to y2 on this piece of the graph of y1. To rule out what's going on to the right of the point of intersection, if you go to the right of the point of intersection, you're then starting to see the graph of y1 being above the graph of y2, and that's definitely something we're not interested in. Alright, so it's this piece right here that's going to help us get our x values that solve this inequality. Alright, I mentioned x values because typically when you're solving an inequality, you want to look for the answers of the variable present in the inequality. And of course, if we were to set up the inequality using these equations, the variable that we'd be solving for is x. So therefore, what we want are all the x values or x coordinates that correspond to this piece of the graph of y1. The easiest thing to do is actually to now go up to your x-axis and then shade the part of the x-axis that corresponds to this piece. Alright, stated differently, all the x values that correspond to this piece of the graph of y1 go from negative infinity all the way up to negative 1.75. Since the inequality symbol has a bar underneath it, what we're going to want to do is include the value of negative 1.75. So I'm going to go ahead and draw a little bracket that points to toward the shaded region of the x-axis. So all we need to do now is just whip up the interval notation for this part of the x-axis, and I'm going to put that down here for part B. By default, parentheses on negative infinity, comma now, and now negative 1.75. And again, due to the fact that there's a bracket under here, I'm sorry, a bar underneath the inequality symbol, we'll use a bracket on negative 1.75. Alright, and that's how you solve this problem using the graphing calculator. Of course, we incorporated some of the intersect feature. But the biggest thing here is to interpret the inequality symbol and figure out which parts of the graph are going to help you solve that inequality. Alright, I hope you find this video helpful. Feel free to let me know if you have any questions. Otherwise, I'll see you in the next video. Thanks for watching.